Okay, so hello everyone and welcome to the Dandelion Physics series. And today's video will be about the first lesson upon our topic 1.2. Okay, so at this point, we have already finished the topic 1.1, and in future videos, I'm going to record the videos about topic 1.2 around like 3 to 4 videos, and after that, we will be completing our unit 1. Okay, so in this video, we're mainly focusing on the concept of the random error. And before I dive into this concept, I have some other concepts that we have to overcome first so that we can better understand the idea of the random error. Okay, so first, I'm going to tell you guys about a concept that is the accuracy. And so when you're in school, or it's like when you're doing a problem correctly, then your teacher will probably say, "Oh, you are very accurate." And when you're doing a math problem, maybe, and your friend will probably say, "Oh, your method is very accurate," or your result is very accurate. So what does accuracy actually mean? So in physics, when we talk about the idea of accuracy, we mean that how close is your experimental value to the theoretical, which is the correct value. And what does that mean? So when you're doing your experiments, there will be values that you're getting from your experiment and comparing the value that you got to the correct value, like how close they are. And here I'm going to give you an example here. So let's say that in an experiment and you have completed 3 trials, and then the trials are, the values are 99, 98, and 97, and the correct value, which is the theoretical value here, is 100. Okay, so in this case, 99 is the most accurate, and the reason being 99 is the closest to 100 comparing to these two numbers. Okay, and that's the idea of accuracy, is about how close is the value that you got comparing to the correct value here. Okay, then after the accuracy, we're going to focusing on the idea of precision. And what does precision mean? So we have 2 cases here. And the first case is about the instrument. And the instruments just means that the tools and those machines that you're using during your experiment in order to measure the values that you want to measure. Okay, so precision is really about the least count of the instrument that you are using. And the idea of least count, I'm going to provide you a few examples here. So first, let me change the color. I'm going to use green color. Okay, so here, I have 3 rulers. The first one, here it says 0 meter, 1 meter, and 2 meter. The second ruler, 0 centimeter, 1 centimeter, and 2 centimeter. And the third ruler, 0 millimeter, 1 millimeter, and 2 millimeter. Okay, so here, the least count just means that what is the smallest value that you can possibly get from the instrument that you are using. So in our first ruler here, the smallest value that you can measure is 1 meter. And 1 meter in this case will be your least count. And in your second ruler, the centimeter one, the smallest value, your least count will be 1 centimeter. And in this case, obviously, will be 1 millimeter, and that will be your least count. The smallest value that you can possibly measure from the instrument that you are using right now. Okay, and then in the second case will be about the experiment. So when you're doing your experiment and you're trying to gather your data, so in this case, the idea of precision in this case means the consistency of the data that you are getting. And what does it mean by the consistency? Okay, let me give you a few examples here. Okay, so first, let's say in an experiment, you have completed 3 trials, and the first one is 1, second one is 1.1, The third one is 0.9. Okay, so here 1.1, 1, and 0.9, they are really close to each other, which means that the difference between these values are really, really small. And the consistency just means that how close the values that you are getting, how close are they? If they're really close to each other, then it means that you have a really high consistency in the data that you are getting. And so let me give you another example here. So let's say in an experiment you got 1 and then 12 and then you got like 90. So in this case, you have a really low precision, which means that like your data here is not consistent because the difference between these values are really, really huge. So they are not consistent. So when you are doing your experiments, if you want to make your data really precise, you have to be your data have to be really consistent. So they have to be really close to each other. And here I have two diagrams. One is for accuracy and then one is for precision. And I'm going to show you the concepts that we just talked about in a diagram here. Okay, so for accuracy means how close you are to your correct value. And here we have a correct value. So if you are accurate, it means that the values that you are getting is really close to the correct value. And there is another case that, so let's say that you are getting the values like this. So value here, 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 and here, 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 here. So on the left side are the values that is smaller than your correct value, and on the right side are the values that are higher than your correct value. And if you take the average of these values here, you will find out that the average value is really, really close to your correct value here. So in this case, your data is really accurate. And in terms of our precision here, so we talked about that the idea of precision is the consistency of your data, which means that how close the numbers that you are getting. So let's give an example here. So if I have a really, really high precision in my data, it means that the data that I'm getting are really close to each other. Like really close to each other, really, really close. They don't have to be accurate. They don't have to be really near to the correct value. But if we're just talking about the precision here, then it means that they have to be really close to each other, really close. And that's the idea of precision. Okay, and then I'm going to give you guys 4 cases that you are going to encounter when you are doing your experiments. And before we dive into that, I'm going to tell you a fact that everything has an error. No matter how perfect the design of your experiment is, no matter how precise you are, no matter how precise you are, no matter how accurate you are, you will always have some errors in your experiments. It's just inevitable. The error will always be there. It's just sometimes that we cannot even detect where is our error, but it will always be there. Okay, so 4 cases. The first case is that you don't have a really correct data, and your data is not precise either. So here are our values here. So if you take the average of them, it will probably be here, and that's kind of far away to the correct value, which means that your data is not accurate. And since these values they are really spread out, it means that you don't have a high precision either. So in this case, not accurate and not precise. And then the second case. In this case, we are both accurate and precise. So as you can see here, the data that you are getting, they are really close to each other, which means that they are precise. And if you take the average of these values, then it's really, really close to the correct value, which means that your data is accurate. So congratulations. So if you're getting these kind of results, then it means that you are a really, a skillful person in science. Yeah. And this case is really rare. It's like it's nearly impossible to get the results like this because sometimes the error are too big and you can't control it, and that will result in like you're getting some values like here or here. So yeah, so this case is really rare. And then our third case, you are not accurate, but however you are precise. And how does that work? So if you take the average value of these data that you are getting, then you are really far away from your correct value, which makes you inaccurate. But however, since these values are really close to each other, it means that they are precise. Yeah, really simple idea here. And the last case is that you are really accurate, but you are not precise. You are accurate because if you take the average value of these values here, then it's really close to your correct value, and that makes you accurate. But however, since these values, these numbers, they're really spread out, it makes your data not precise because these data are not consistent. They are not close to each other, so that will make you really less precise. Okay, so we're going to proceed. So after those concepts that we just learned about, then we can dive into the idea of random error. And later on, I'm going to call the random error just the RE. Yeah. Okay, so then, what is random error? What is it? And I'm going to tell you that if you are having a lot of random errors, if there is a lot of random errors in your experiments, then it's all your fault. It's all your fault. I'm sorry, it's kind of mean to say this, like it's all your fault, but that's actually true. Because random error is also called the human error. Human error. It means that, like, when the recorder or the operator of the experiment, when they make some mistakes, it means that they're producing a random error, which they're made by humans. So it's human error. We are making the random errors. And as an example here, so let's say you're trying to measure the reading of your water surface here. Yeah, here. And the ideal case is that you are observing this marking here really horizontally. And that's your ideal case, because in that case, you will be really accurate. You will be getting the results that is really accurate. But however, sometimes your eyes might be a little bit higher, and sometimes you might be a little bit lower, but you don't know. Sometimes you make those mistakes, sometimes higher, sometimes lower, but you don't know because you thought you were really horizontal, but you're not. So when you're higher, you might say, oh, it's 9.8. When you're lower, you might say, oh, it's 10.1. But however, the correct value is 10. So in this case, you are making the random error here. You are making errors because of your own mistake, your own measurement mistake that will produce the random errors. Okay, and then in our second example here, that we're trying to use a ruler to measure the length of this, I don't know what is this, a tube or a rope. So we're trying to find the length of this rope here, and the marking is here. But we don't know what the marking is here because our least count is about 1 millimeter. Our least count is 1 millimeter, but however, it is between that's 1.2 millimeter and what am I talking about? It's between 1.2 cm and 1.3 cm. But however, this is our limit. That's the smallest value that we can measure. So what can we say about the value here? So Steve says that, oh, this value is around 1.1 to 1.3 cm. So let me mark it here. So 1.1 to 1.3. And Annie says, oh no, it's around 1.2 to 1.4. 1.2, wait, sorry. 1.2 to 1.4. And who is correct? So in this case, since we are not sure, like we know the value is around this region, but we don't know specifically what the value is. So in this case, even though they're arguing, oh, I'm correct, but they are both correct. In this case, we only know the range. We don't know the exact value. So in this case, they are both correct. But however, we are making a random error here because we only know like the range of like the value that we're trying to measure here. We can only give a range. It's around here to here. But however, due to the least count of our instrument used here, we cannot know the exact value of this rope. So here is the random error that we are making when we are measuring. It's caused by us because we are making the decision of which range should it lie on. So that will be our random error. Okay, and then we're going to talk about a thing here is that the random error is going to affect your precision. And we all know the concept of precision is the consistency, how close your data is. So your random error is going to affect that. And why is that? Why is that the case? Because okay, random error is random. As we discussed above, you might take the value a little bit higher, you might take it a little bit lower. So it's completely random. You don't know in the next data that you are getting, is it going to be higher or lower? You don't know. It's completely random. That's why it's called a random error. It's so random. It might be higher or lower, but you have no idea. So in this case, in our diagram, we're going to record our values like this. So in our first trial, it might be here. Second trial here, third trial here, fifth trial here, fourth trial here, fifth, sixth, and blah, 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 blah. So it might be higher, lower is completely random. And that's why it affects your precision. Because precision is the consistency of your data. It's how close your value is. So if you're having a really huge random error, it means that in the first case, like your value is here, and second one is here, and here, and here, and here, and here. So your values are really spread out because the random error, you don't know. The next measuring, is it higher or lower? You don't know. So that will affect your precision, the consistency of your data. Okay, and here is another idea of the direction of error. So here, we have observed that random error can be higher or lower. Higher or lower, you don't know. It's completely random. So in this case, it's two-sided. Two-sided. It's a two-sided error because the value that you're getting can be higher or lower. You don't know. So it's two-sided. And that's what I mean by the random error. It's totally random. You don't know what's happening. You don't know whether it's going to be higher or lower. But what you know is that this error is caused by you. It's your fault. Yeah. But however, why does this happen? So two of the most classic case will be that the first one, the instrument is imprecise. So it's giving like fluctuating values, which means that so if you have a measuring scale and the reading of the scale is not precise because the instrument is so old. So if it's not precise, then it's going to create some random errors. So when you're taking the value, you are going to make some random errors. And then the second case is the inaccurate determination from the recorder. And that's what we talked about here. The determination of the recorder. So in this case, Steve said it's here. Annie said it's here. But you don't know. So that's our determination about which value should it be. But when we're making our own decision, there will be random errors because we might be like slightly higher or slightly lower. We don't even know when we're doing the experiments. So in this case, it's going to cause a random error. And you might ask, well, it's so random. It's completely random, and I don't know what should I do about it. So here, how do we improve it? How do we improve our experiments by reducing the random error? And in this case, you saw me doing so. You saw me circling this word here, reduce. It means that, so what I'm trying to tell you here is that you cannot completely eliminate random error. You can only reduce it. It will always be there. You can only reduce it, but you cannot completely eliminate it. Because human is always going to make some errors. No matter how precise you are, no matter how careful you are, there will always be mistakes that you are going to make. Trust me, you are always going to produce some errors. So what you can do is only reduce the error, but you can't eliminate it. And here is a really classic way of reducing it is to do more trials. So as we saw previously, so let's draw another diagram here. And here is your correct value. And here are the values that are smaller, and here are the values that are bigger. So in this diagram, why am I saying that we should do more trials? Because the first trial is higher, second trial higher, third trial lower, fourth trial lower, and then lower, and higher, lower, higher. So if you do a lot of trials and you take the average of them, it's going to be close to your correct value here. But however, if you only takes a few trials, then your value it might be something like this. So it's like here. So if you take the average of that, it's going to be here, and that is going to be really not accurate. So in order to improve your data that you're gathering, so your goal is to be as close to the correct value as possible. So what you can do is to do more trials. So in this case, if you're going to take the average of the values that you got, then you can be accurate because the average value is going to be really close to your correct value. Okay, so that's all about our random error here. And that is really all from Dandelion today. And if you have any questions, please comment down below. And if you would like to stay tuned for further videos, please click subscribe. And I will see you next time.